when you ask adults about their elementary math experiences, rarely do they tell you that they loved word problems and that it was their favorite part of the math lesson. In fact, we know that word problems typically have the opposite reputation. Why is that? Well, I propose that the difficulty is that children feel ill-prepared for the challenges of math problems. Now, it isn't the challenge itself, because a lot of times when people do challenging things and persevere and work through it, they feel a great sense of achievement and enjoy it even though it was hard, sort of the idea of hard fun. But they have to be prepared for how to deal with that challenge, what to do to persevere through it. So it's not like hitting your head against a wall, but there is a productive pathway that you could pursue that will get you through the challenge. What we need to think about then is how we're preparing children for the challenges of problem solving, especially as they're getting started and having their very first experiences with problem solving. We want to think about how to get that started off right. Well, the first thing you need to do, and this needs to happen early in the school year, is to ensure that the prerequisite skills for successful problem solving are being actively addressed and developed in the classroom. And we discussed those in the previous lesson, but to quickly review, children need to have cardinality. They need to have a sense of quantities and what those quantities mean. They need to be able to use that knowledge of cardinality to count out real objects and be able to say what a set size is. They need to know the number word list well beyond the numbers in which they're working. And they need the ability to act out a situation. Very likely they're going to develop that experience or knowledge through the kinds of things that are happening in the classroom, which is what we're going to talk about. Next is how to develop that. It will likely begin through some collaborative problem solving. And collaborative problem solving is where you engage the whole class in solving a problem together. And that will involve you asking some questions and prompts and supporting them and getting it acted out. Problems could be related to a lot of daily routines, such as attendance, snacks, classroom materials. Here's an example. You could say, there are 5 pencils in this container. One of them went missing over lunch. How many pencils will there be now? What could we do? And so you can develop problems about all kinds of classroom things. Read-alouds oftentimes have some opportunities to mathematize situations. Some books were actually designed practically for that use. They're so good at it, such as Roosters Off to See the World and How Many Snails. But there are other books where if you look for an opportunity, you can develop those opportunities. And then you can collaboratively act out the problem with the students, as I suggested. Here's an example of a book, Two Little Dicky Birds, that could easily be designed for you to act out with the children. And they could pretend to be yellow birds and blue birds. And you could either choose people who are wearing that color of clothing, or you could have them hold a colored picture or a picture of a bird, and they could act out this particular story. So there could be questions about how many bluebirds, how many yellow birds, how many birds altogether, or there could be stories about the birds that stayed on the wall and the birds that flew away and now how many are left. But they act them out first, and then they can then you can get out some counters. You can say, let's choose some yellow counters for the yellow birds and blue counters for the blue birds, and let's act out the same thing. This is an important step because the counters represent a different level of abstraction. So here you have the people acting it out, the visual image on the page, and the abstract blocks representing birds. And they're seeing it represented in 3 different ways to help them get the relationships embedded in their mind, and also help them to see how materials such as blocks or counters can be used effectively to model situations. The primary goal in all your work with children is to help them visualize relationships as a tool for understanding those relationships that are embedded in the words. The visualization efforts that you make are fundamental to their sense-making to allow them to mathematize that situation. Pull out not just the numbers, but the relationships between the numbers. And it should be actively fostered. In this case, it actually works well that it's also something that will have to be actively fostered in the literacy strand. Early in the school year, you can make efforts to do some collaborative visualization, and you can model this yourself. You can model what you saw in your mind, and quick images where you hold up an image and then put it down and say, what did you see? A lot of times we use dot images or TINS frames. This was discussed in Part A module. But if you use quick images, then a lot of times early in the year you can model. I remember seeing 3 dots on the top and 2 dots on the bottom. And so you can model that out loud, and then you can ask students later, now that you've modeled it, what did you see? So think about how you can get the students to talk about what they see. You can have them talk to their partner, their carpet partner, about what they saw. And the questions have to be geared towards the specific problem that you're discussing, but these are some examples. Who is this problem about? How many did you see? What happened? That's good for an action problem. What happened in this story? And then how are they arranged could be useful for another type of story. Later, when children start individually problem solving rather than just doing it in whole group, you may encounter a child who's struggling. You almost certainly will. It would be best if you thought as your base tentative hypothesis that their problem is likely a visualization problem. It very often is. So before you actually go into, let's use these blocks, let's do this, it's really important to make sure that they visualize the problem and spend as much time. I've worked with students who struggle. I remember in particular, second grade child, we worked for days on just visualizing a problem. He never got to even solve it. It was always, can you just get to a point where you can do a retell? However, that paid off enormously, because once he got to the point where he could visualize, his progress was unbelievable. So take the time to really help them visualize and make that feel like the ultimate goal, so that if they don't get to the solution, it's not a failure if you can get them to the point where they can visualize. Take the time to do that first. So these are some examples of visualizing prompts that you can use when you encounter a child who's struggling, and that can help focus their attention on what's important for children to do first. Before we start grabbing blocks, before we start drawing a picture, we have to be able to visualize what's going on. Tell me what you see. Tell me what the story is about in your words. Tools that you can use, well, yourselves, you consider using mini dramas so that the children themselves are acting out the problem. You can focus on the quantities, however, as you act out the situation. Don't get too drawn up in, say, costumes or that type of a thing. Keep the focus fairly simple so that it's really drawn to the idea of the quantities. Storyboards, we're going to see a few of these in a minute, but they're background scenes that children can use to act out problems. Realistic manipulatives look like the thing the problem is about. So if your problem is about cupcakes, you have actual cupcakes or you have pictures of cupcakes. If the problem is about cars, then you have little matchbox cars or you have pictures of cars. Also, you can show them pictures with embedded math stories, and I've shown one from Early Bird Kindergarten Mathematics here. This one has several different things that children could mathematize, and if you regularly introduce this as part of something you do in math class, the children get pretty good at it. You can say, what do you see in this picture? And the children can say, I see 3 yellow birds, I see 1 brown bird, I see 4 birds altogether. So they're beginning to do some of that, and that can be collaborative. You can have them talk with one another. There's also the flowers and the ducks. There's 5 ducks in the pond, but 2 are adult and 3 are small. So those are important things to talk about. These are storyboards. As I said, they're a background scene that you can use to act out the story with some counters or some realistic manipulatives. What I've shown here are realistic manipulatives where it looks like the thing the problem is about, although you can also then have them do it 2 times. Do it first with the realistic, then take that away and say, do the same thing now with these counters. And that helps to transition them to using a more generic counter, which is a incremental step towards a little bit more abstraction, and also helps the child get to the point where they lose their dependency on realistic counters, because let's face it, realistic counters aren't always available, but more generic things often are. Now what we're going to do is we're going to take a look at some common problems that occur when children first start problem solving and brainstorm a few things that could be possibly done to help avoid that problem. And the first one we're going to discuss is elaborate drawings. Oftentimes children, both of my girls, for example, prefer to draw rather than use manipulatives. And I sort of hypothesized that that was because they had more control over the drawing. They could decide how to draw it, how to arrange it on their paper, how they wanted to use it. Whereas if they were to go and get counters, for example, then they had to think about what will I do with these to represent the problem. So they started in their earliest problem-solving experiences doing a lot of drawings. And the drawings sometimes take very long. I'm sure if you've had some experience with kindergarten problem solving, you'll know exactly what I'm talking about here. And so it's very laborious for them to model these problems and draw a lot of non-essential details. And sometimes I've sort of wondered whether a child feels good about their drawings, so they put more details because they don't feel very good about their being able to do a solution. So I don't know if that's always the case, but one thing I do know is that we want to get them to the point where they can use a more generalized model rather than elaborate drawings. This is an example. The problem here is there were 9 children at the park, and then 8 children came to the park. Now how many children are at the park? And you see here that this girl drew actual people, and it was laborious and time-consuming. And you'll notice that the very last 2 she drew were puny because she got kind of tired of doing it. It was so difficult to draw the first 9 children that the 8 more arrived at the park was just like grown what to do. That was actually really ideal, though, because it provided an interesting opportunity for me to engage with her and talk about the fact that was really a lot of work. Is there something else we could use to make pretend children rather than drawing them? And she looked around and decided to use Unifix cubes. So she got the 8 Unifix cubes and then counted the 9 children in her drawing and the 8 Unifix cubes that she had and came up with a total. And it wasn't long after that that she began to transition out of using these elaborate drawings. So one thing that you can do is to help a child at the time that they are finding it laborious. As you work with a child who's doing this, please don't compliment their unnecessary details. You don't want to validate it. You don't have to say anything negative about it, but don't say, oh, what beautiful little people. Look, you've drawn eyelashes and such details. You don't want to validate the thing that's actually not appropriate in this setting. Instead, validate the aspects of the drawing that are mathematical. I noticed that you drew exactly the number of children that there were originally. Okay, or I notice you have the same number of items as was in your problem. So validate the features that are what you want them to be doing rather than the features that are not. Provide number sets or items that are going to be a bit laborious to draw, and that should be tiring enough that they will be really interested in something that's less work. Also, you can take 2 students, both of whom drew, but one, let's say, drew something that I would call more iconic, like circles, or tallies, and the other one did an elaborate drawing, and have them share with one another how they solved it and what worked. And then I would try to say at this point, which one of these do you think took less time? Did it still work? Could you do that next time? Because you worked so hard. I hate to see you go through that much work. Do you think you could do this next time? So those are some suggestions I would have for getting the students off of the elaborate drawing mode. Sometimes I encounter children who just look helpless, like they couldn't possibly think about what to do first. And when you suggest that they act it out, they act like they've never heard these terms before. So what are some suggestions here? Well, first of all, I want to make sure that they have the prerequisite skills. So can they count? Can they count out real sets? Do they have cardinality? Do they have the number word list? And what has been their response in previous experiences where we collaboratively acted things out? Is there something there that I could signal in their minds and memory that they could bring to the forefront that would help them in this particular task? So I'm going to evaluate the prerequisite skills. It's possible that maybe they need a little more collaborative problem-solving experience, perhaps with a parent helper or an aide who could provide more oversight but trying to turn over that responsibility actively to the child. So maybe some prompts, but the child has to do all the work. All right, so if you have a problem about 3 sheep being in the barn, don't pick up the sheep. Show them some counters and say, which of these counters would be appropriate for this problem? 3 sheep were in the barn and 2 sheep were out. Choose some. How many should you choose? Do we need to read the problem again? So you don't do anything for them, but you, through prompts, kind of collaboratively are guiding them sort of step by step, but you're not telling them what to do. Initially, when they're in this mode, stick with some realistic counters or images. However, I strongly suggest that you do the problem twice, the first time with the realistic, and then say, what if we didn't have any sheep? Here's some cubes. Pretend the cubes are sheep. Do the problem again, just like you did it, but we're going to pretend the cubes are sheep. So this is to facilitate that transition that you're going to want them to make. Consider the use of storyboards, such as the ones you see here. These came from a Kathy Richardson source, Counting, Comparing, and Patterns. And I colored them and laminated, well, actually covered them in plastic. They've got some cardboard in the back, so they're more durable. And the students can use these to do some problem solving initially. Eventually, I phase these out. When I think they don't really need them anymore, I'll say, oh, I don't think you need that. Why don't you just, you've got a piece of paper here, pretend that's a barn. So I'm constantly trying to incrementally shift the students towards greater levels of abstraction. Another problem that you sometimes see is where a child has trouble with blocks and counters. They don't know how to use them to represent items. So if the counters don't have meaning, it's probably going to mean that you're going to have to fall back to those realistic counters, such as the ones we just saw. If the problem is about sheep, then we want to find sheep. If I have no sheep available, I'm going to make up a problem about blocks or chips, so that the thing the problem is about and the thing that they're working with are the same. However, I would like to transition them to being able to use a more iconic representation, such as dots, circles, chips, blocks, rather than always having to have that regular thing. So again, I'm going to give them problem-solving experience where they start out with the realistic, and then I say, do the same exact problem you already just did, now use these. Does that work? Right, when they're done? Did that work? Could you use these as well as these? Right, because I have these around a lot more. So you can follow through with that. So our summary here is to foster connections between levels of abstraction. Notice that several times I showed where they did it one way and then they did it a second time or a third time, again getting slightly more abstract. Mind you, we're still working with fairly concrete images or pictorial visual images, but they're always starting with the child's current level of understanding. That's where we begin. And then stretching that just a little bit to that next level of abstraction. And the second really critical idea that we've talked about is the importance of visualizing and sense making in order to really mathematize situations, and how when a child is struggling, that's your number one goal. Not solving the problem, not getting an answer, but learning how to visualize and make sense, because that is going to be far more powerful for all of their subsequent problem-solving experiences than whether they found out that the answer to a problem is 5. So the visualization, building those basic problem-solving skills, is really critical. Next week, we're going to follow up with these ideas by really taking a closer look at children's representations, and we've already made some references to those.